Hi! So let's do some computations in MATLAB. First we would have to assign some value to a variable. Let's call the variable x. And this is how you do it in MATLAB. To the left of the equal sign you put your variable name, and to the right you put some value which you would like to assign to this variable. So here we say create variable x and let it be 0 for a while. Okay? Once a variable is defined, you can use it as an input to other definitions. For example, we define y as x plus 2. And please observe here that y is not a function of x. Y is just a scalar, right? So it's just a single value defined as the current value of x plus 2. That is, should we change x, y will not change. Okay. The whole finance is all about vectors and matrices, right? And we have to find a way to deal with these guys in MATLAB. This is how you create a matrix. Oh, let's start with a vector. So you use square brackets. Square brackets stand for a matrix or for a vector. And you input some numbers and you separate them with either a semicolon or with a comma. Semicolon stands for please stack my values on top of each other, thus creating a column vector. This is a column vector. And a comma stands for please put my values next to each other, thus creating a row vector. So y would be a row vector. Here I have to stress that it is absolutely important. It is compulsory, in fact, for you to think of vectors as of column vectors, unless otherwise stipulated. Vector x means the same as column vector x. Okay? Always think of vectors in terms of columns. Otherwise, we'll have to kill you because you'd get into a lot of trouble doing econometrics. That said, y isn't really a vector. Right? Because, we've come to a conclusion that row vectors don't really exist in MATLAB. So we would have to transpose it. And in order to do a transpose in MATLAB, you put a dot and a prime close to something you would like to transpose. So now y is a neat and beautiful column vector. In case you really want to have a row vector stored somewhere, please call it y prime or y row or, I don't know, y weird or something, okay? Like that. Okay, in order to create a matrix, you do the same trick. You concatenate some things either row-wise or column-wise. In our case, you place column vector y next to a column vector x, thus creating a 5 by 2 matrix. Here it is. Okay, now we are ready to do some operations on vectors, and there are two ways in MATLAB you can do it, either element-wise or matrix-wise. Element-wise always has a dot in front of an operator. For example, this guy means please divide every element of x through a corresponding element of y. That's how it goes. Or, for example, this guy, which means please raise every element of x into a power corresponding to an element of y located on the same spot. Okay, 9 to the power of 8 is this ugly beast here. Okay, matrix-wise computations are performed by specifying an operator without a dot. So just simple multiplication and division and powers and whatnot. So for example, let's compute the inner product of two conforming vectors. Inner product is an important concept in linear algebra, and this is basically a row vector multiplied by a column vector, thus resulting in a scalar. So here we go. And this is the outer product, which is a column vector multiplied by a row vector. And this is, of course, a square matrix. Okay. let's see if you can discriminate between those guys. So the outer product of two vectors of equal length is of course a square matrix. And if we raise it to the second power without putting a dot in here, this would be effectively the same as multiplying this matrix with a transpose of it. That's how it goes. Okay. Otherwise, if we do place a dot before the power operator, what would happen? Exactly, we would have squares of each element of that square matrix. Good. Awesome, in fact. Well, here I've written most, but all functions in MATLAB are vectorized. That is, you can simply input vectors and matrices as arguments. Taking logs or taking, square roots. Okay. Now, if you want to index a matrix, you use parentheses. Not square brackets, not curly brackets, but parentheses. And as the first argument, you input the row number. As the second argument, you input the column number. So xy22 is the second row, second column element of our matrix xy, which is 5. If you want to select all the rows or all the columns, you put a colon instead of an index. For example, this guy says select all the rows of column 1. And that's what MATLAB did. And is a useful operator when used as an index within the parentheses. And it effectively says, okay, find the last row number or the last column number. So from 2 to n minus 1 effectively means select all the rows but the first and the last one and all the columns. Very well. Okay, now we're ready to do some finance, and let's start with returns calculations. You would usually see data in forms of vectors. For example, x is your vector, says those are the stock prices of some company. And you want to calculate a simple arithmetic returns, which are defined as x at time t divided by x at time t minus 1. And minus 1, of course. So, that's how people do it in MATLAB. They take all the values but the first one, and they element by element divide them through all the values but the last one. And thus, what you effectively get is exactly this xt divided by xt minus 1 value. So let's do it. Here are our arithmetic returns of x. If you just want to take the difference of x, so xt minus 1, you can use this neat function. Or alternatively, do the same, but substituting dot left divide with a minus. So difference is a handy and beautiful function. For example, when calculating log returns, you just put the difference series of your logarithmic transformation of the original series. Okay, and that's how you get your log returns. Awesome. So now with our freshly gained knowledge of matrix algebra in MATLAB, let's do a linear regression. We'll regress log ret y on the x and a constant. So first we have to create this a constant. And we use our concatenation technique. We concatenate a vector of ones. This is how you input a matrix of ones with 4 rows and 1 column. And the second stuff we want to concatenate is our dx. So once again, nothing special, we've seen it before, and well, dx is yet undefined. Now it works. So this is our capital X, our new x. First column stands for a constant, okay? And using standard formulas, we can calculate the inverse of x prime times x prime times y, which is effectively our beta. We see that our alpha is 0.2 and our beta is close to 0.1. Using matrix multiplication, we can calculate the predicted values and the fitted residuals. Using the inner product, which we have seen before, we can calculate the residual variance. Once again, inverting some matrix, we want to calculate the variance matrix of our estimates. And finally, the t-stats are defined as simply the beta element by element divided through the diagonal of our estimator variance covariance matrix. So we see that in our simple model, alpha is not statistically significant, whereas beta is on virtually any significance level possible. So thanks a lot, guys, and stay tuned.